You've probably been familiar and exposed to so many different machine learning tools as you're probably growing up right now, whether it's in the world of healthcare, whether it's in the world of music, even like purchasing and buying, right? I think the world of machine learning, it's so incredibly rich and powerful that you've probably seen it just in about everything. One of the things that I got a chance to ask my students during lecture was of the students that were coming, how many were basically taking BART, right? And there's a lot of students that came to this class on BART. And here, let me draw like a quick. Uh, this looks more like a car, but they're coming to class on BART. And I asked them of the students that were basically coming to class on BART, how many of them were basically listening to music on the train. And all of the students, quite a few of them, like just about all of the students basically said they're listening to music. And I asked them what sort of music were they listening to or what sort of platform they're using. The vast majority of them said that they're using Apple Music. The other folks said that they're using Spotify. Actually, Spotify was the one that received the most votes. And then the last was SoundCloud. Funny enough, I also have been using SoundCloud, in part because my sister took me out of her Spotify plan. Not in a bad way. I think it was also because I've not also been listening to music as much, or I have not had like a whole lot of time to listen to as much music. I've basically downgraded, or in other words, upgraded to SoundCloud. Upgraded in my ways and downgraded maybe in your perspective, right? So there are these three major platforms where a lot of people end up listening to music. And what's incredibly powerful each of these platforms is that let's say that you've been listening to Drake. We know that he is a good artist. Maybe some feel a different way after the Super Bowl. We know that he's a great artist. And let's say you've been listening to five songs by Drake, right? Let's call that song, I don't know, Hotline Bling or something like that, right? Hotline Bling. Um, and well, there's a lot of songs, so I'm not going to comment out on each one of these songs. Take care. A lot of these different songs by Drake, right? And after you listen to a lot of these songs, then you stop thinking, right? Like you start thinking, like the entire playlist that you have on Drake, that you have on Drake. You have song one, song two, song three, song four, song five in this specific playlist. And after song five, there is no more songs. So if you're listening to this in any one of these platforms, what this platform is basically going to do is it's going to recommend you a new song. So you could think that if you've been listening to a lot of songs that are already pop, more than likely you could basically imagine that the very next song that this algorithm is going to give you is also going to be pop, or it's going to be hip hop, right? So you can see that the way that a lot of these machines they're basically making decisions is in large part because of the past data that you give it. And beyond the past data, it's also thinking about other people that are on the platform that listen to Drake. What do they like? So this model is just asking you a very simple question. Of the other people that are listening to Drake, what do they like? And it's going to basically recommend you a song based on this, right? So when I think about this entire process that's basically happening, I can basically layer that uh, into two different events. Number one is uh, number one is basically I can basically layer that into two separate events. Number one is thinking about past input and thinking about next output. Now you're probably saying, wait, this sounds pretty familiar to me. Past input and the next output. It sounds like something a function might do, right? So you have past input, and then based on the past input, it's going to give you the next output. Instead of past input, we can basically say past songs and next song, right? So based on the past songs that you've listened to, more so the other people on the platform, the genre that you have liked, all of these values are basically going to be used to determine the next song. And when I think about any sort of machine learning model, I think it's also similar that machine learning in essence is just a way for computers to be able to learn from data and make decisions without being explicitly programmed. I think this sentence explains machine learning in a really good way, right? It's basically saying that it's a function that uses past data to make decisions on its own with math. And a lot of the stuff that we see during this course is it really relates to thinking about how we can use some of this intuition, like the example with Spotify, to be able to think about and create some sort of a mathematical model so that we can hopefully create things or create platforms that might be a lot better than Spotify, right? So we can always think of it in terms of functions, and we can use this past data to be able to make decisions with mathematics. So that's the crux of what machine learning is. But if we were to go back to the same Spotify example, what is the very first thing that the model does? Or what is the very first thing that we do? We ask a question. That's a question. Right? So, what exactly is a question, you might ask? Well, a question is just a very short and a concise statement, or not a statement. That's pretty paradoxical, but a question is a very concise and very concise yet deep uh, problem that you're basically trying to solve, right? In this case, it is what's the next song we should recommend to, in this case, it is, let's say, to Srijal, given he is listened, given he has some input. What's the second thing that we do? We store the data. This one's kind of obvious because when you think about storing the data, I already talked about some input. You're getting some input, and using this input, you're using that to basically make some sort of a decision, right? So you're being provided some sort of an input, and you have to store the data, right? And right after you store the data, what you might say is you want to basically visualize the data. And after you visualize it, you might analyze it further. Then you create some sort of a model. In this case, the model might be, it's basically the model is the answer to the question, in the sense that it's basically saying we want to map some input to an output. In this example, for instance, past song history to the next song he should listen to. Right after that, we deploy the model. I think that's what's pretty incredible about machine learning is when you kind of, I'm going to group these into the data bucket, by the way. When you kind of zoom out, a lot of these processes are really, really simple. When you think about a question that you're basically asking, in this case, it's what's the next song that we should recommend to Srijal, given he has some input. You might have some sort of a data sheet that looks like this, right? And in this data sheet, you might have how long he listened to some song, at what time, a bunch of these different features, right? Features basically meaning column values, right? So column values, if I were to simplify that even further, it would probably be, each row would represent how long. So 3 minutes, 5 minutes, 9 minutes, even 30 minutes, right? For some song, X, Y, Z, K, and then for some at some time period, let's say it's 2:30 in the morning, 3:30 at night, or you know, 11 a.m. in the morning. So you're basically having, and to even make this even more concrete, let's just say uh, 12 a.m. or 12 p.m. At night, right? So you have all of this data that you store, right? And after you start storing this data, you might visualize a certain pattern that certain types of users, right? Let's call this username. Certain types of users listen to a certain set of songs more often than others, right? And you might analyze this even further to see, oh, let me get some more input back. And then right after that, you are going to create some sort of a model. And then that model is going to help dictate what songs you should listen to. And there's going to be a lot of math and coding. And then right after that, you just go ahead and deploy the model. And what's incredible is that you can always come back to the same question once you leave it. So once you leave this data analysis piece, then you might go back to the same, you might go and think about the same question again, right? Or you might refine the question again. And when you're thinking about, the model, you might go back to the same thing, and you might refine the question again. It's really, really, this entire process is very much iterative. Iterative basically meaning that you can come back to the same question or the same principle and always just update them continuously, right? So this is what's really incredible about machine learning and deep learning. I would like to go over like a very small case study that I did come across when I was researching some pretty cool machine learning projects. In the class, I got a chance to ask a lot of these students about where they have what are some applications in the realm of healthcare or biology, and they gave me some really really cool ideas. Really really cool ideas actually, and one of the ideas that I even brought up was, for instance, there are some of these chemical compounds, meaning something like H2O, right? It's because I don't know of any other chemical compounds off the top of my head, but also it's because it's very simple to think about. And H2O is water. More than likely, you guys have all already seen it, right? So there's some chemical compounds, and these chemical compounds happen to be antibiotic. Now, what does antibiotic mean? It just means some sort of a chemical compound that can fight bacteria in your body, right? So, some researchers at MIT, they went through like a bunch of like data, like a bunch of data, right? And a bunch of data to be able to develop this machine learning model. And what it can now do is it can go through millions of data sets, millions of rows of data set to be able to identify chemical compounds that might be likely to be antibiotic. So think about the next time that you're at the doctor and you're probably thinking, I shouldn't be here. Then this doctor is going to give you like some sort of a pill or some sort of an antibiotic to be able to fight this bacteria. And what's really incredibly powerful about it is the fact that this same bacteria, what might have been the result of some sort of a machine learning algorithm. I thought that was really, really cool. So, I'm not sure too deeply about the project that they did down at MIT, but what I can give you is a very simple example, right? So this is an example of what's called tabular data. Tabular data basically meaning data that's stored in a table. It's very, very simple, right? You guys have probably used Google Sheets before in some of your classes or Microsoft Excel. And all of this information, just think about this as the column name, and just think about all of these individual items as the rows, right? And all of these items as rows, and think about a specific compound you have and specific features, right? In this example, mechanism of action, what it exactly does, what is it effective against, what's the molecular weight. Just as a side note, the information here might not be accurate. Some of it was kind of like randomly generated, I think. So take this with a grain of salt, right? And using this, we can predict another row, which is if it's antibiotic or not, right? So again, I'm completely making this up, but might be something like 10010, meaning that Hallison, which I'm glad I picked because it's probably really, really easy to pronounce as compared to some of the other names that I see in this list. Like, how do you pronounce this? Ceftobiprole, might be entirely wrong, but or this is even worse. Erythromycin. So in any case, you can see here that using a lot of these features or these column names, we were able to predict something really, really effectively, like if it's antibiotic, and that's pretty impactful in the way that we basically work, right? Or like the human body works. So it's pretty incredible. And this is let's go back to the same structure that we thought about before. We first thought about a question, right? In this case, the question is, um, how can we create a model to determine if a chemical compound is antibiotic? And right after that, what did we do? In this case, we didn't visualize the data, but we did store the data. We didn't visualize it or analyze it, but we did store the data. So in the last slide, I put this as the data analysis bucket, right? So, but we did store the data, and right after we stored the data, we thought about some model, and right after some model, we thought about deploying the model. So the same exact process that we identified above, it also the researchers at MIT are also doing this, right? So don't think that it's only me making this up. And in essence, if you were to take away anything from this entire presentation, it's the fact that machine learning is just a function. It takes some input and it gives you some output. Similar to how you think about f of x squared. F of x is equal to x squared. And if you put in 2 in that function, you get 4. In this case, if you put in some column values, then you get some output. It's really that simple. What's more complicated is thinking about the math behind it, but I promise you, if you think about it with intuition, nothing in the world is that hard. I think a lot of researchers just like to complicate stuff, and they'll basically speak to you in what might sound like, archaic English, but a lot of the stuff is simple. It's just not well explained. When we think about the different types of tabular data, the first one is called a series, right? Or like at least in this specific class. Series is a type of a data frame. What is a data frame, you're thinking? Data frame is similar to an Excel sheet. This is what a data frame is. All of that is a data frame, right? A series can be thought of as like a segment or a chunk of a data frame. And I'll explain what I mean, right? You can see here that there's only one column. A key thing about series is the fact that they only have one column. That's something that's apparent. And if you're going to middle college, which the vast majority of you are going to, these are indices. Indices can be anything like 0, 1, 2. And column values can be anything like, economics, English, Spanish. This would be this would be one column. You can see this is just one column, and these are just indices. It's not even a column name. So therefore, it's a series. Here's a trick question. If you had something like 0, 1, 2, and you had economics, Spanish, let me just move Spanish down just to keep keep the same format. Economics, English, and Spanish. And then you had something like, let's say, Atkins. This one's Hoffman, I think. This one's Woolery. Question is this a data frame? Or I mean, is this a series? Well, think about it for 1 second. What's the key feature about a series? If you said no, you're correct. It's not because it doesn't have one column, right? This is subject and this is teacher. It doesn't just have one column. It has multiple columns. Therefore, the answer is no. So now you're thinking, wow, what is multiple columns called? It's called a data frame. Simple. Nothing hard, right? In this case, we have teacher name, year started, uh, and favorite activity. And we can see here from this specific column that Mr. Atkins from middle college, he likes making jokes. Mr. Hoffman, on the other hand, he likes to play CNN 10, right? At least for the first 10 minutes of class. And Miss Woolery here, she really likes to teach Spanish, right? Um, que bueno, in the words of Miss Woolery. Que bueno. I hope you I hope you finish this lecture and you also say something like que bueno. It'd make me feel good, even if I can't hear it. So, so this is a data frame. And I'm going to be really brief about this, but this is also another type of way that you can store data, along with many, many other different ways, and that you can do it in Python. Um, you can see here the very first thing that we do from the code is we convert values, all of these different values, to a data frame, right? And then once we convert that to a data frame, we basically say, hey, I only want to include the number. That's basically it. And what this is going to do is it's going to give you some sort of an output that only has numbers, right? So I'm not going to touch a lot about PyTorch in part because we're not going to cover it as much in class, but I think it's still worthwhile knowing. Next time around, we're going to go over a lot about supervised learning, and this is where the real math starts, or in other words, the real fun starts. So what I'm saying is math is equal to fun. Might be a boring joke, but I think it's pretty funny. In any case, we'll basically go over all of this information in the next slide or the next presentation, and we're going to derive something that I think is pretty cool. We're going to derive a supervised learning method the next class from scratch, and afterwards we'll see some live coding. But more importantly, I hope that you guys basically, at least from this lecture, got some inspiration to think about how you can use machine learning on your day-to-day lives. And hopefully, after you watch this presentation, you can kind of take some time to reflect on the different things that you see on your day-to-day basis, and how it could basically be improved by using data science and machine learning. So I really hope you enjoyed that lecture, or I hope you enjoyed the lecture. And thank you so much for your time. And the world is changing. Cool. Bye-bye.